All right, guys, welcome back. Um, it's midterms week, so I hope everybody is passing all the midterms, surviving, and getting enough sleep, and staying hydrated. So for this video, I browsed through your guys' sample midterms, and I've kind of just compiled, I guess you could say a list of the two main things that you guys have been doing so far. And so first off, I'm gonna go through just a very general review and kind of my tips and tricks for each of the things that you guys have learned so far, and kind of just going over reiterating some important properties and things to remember going into the midterm. So first things first, at the very minimum, to do any of these problems, there's a couple of things that you guys need to know, right? And so this is our base knowledge, right? So you should have a very strong understanding of derivative rules and those properties, integral rules, those properties, all of your antiderivatives, right? So this is theorem 5.1 from 5.1.2, right? So I'm not saying that you have to memorize all of theorem 5.1.2, but there are certain things I would recommend you guys getting super good at, and that's the trig identities, the power rule, or the backwards power rule for you guys, and logs, which are kind of the big things in theorem 5.1.2 anyways. But those things come up all the time, and those are very prime integral questions. So I would definitely say that make sure that you have a strong understanding of theorem 5.1.2 in those senses, so that when you do take your midterm, it is a time test, you'll be super quick about it, right? And so the next big thing that we've covered is integrals, right? So with integrals, right, so it's integrals in general, but if you can do a definite integral, you definitely can do an indefinite integral, right? But just remember, when you're doing an indefinite integral, plus c matters. Do not forget your plus c's. But we mostly care about definite intervals, right? So remember that definite intervals define the area under the curve, right? So anytime they're asking you for some type of area, it's going to be in the form of a definite integral, right? It's always very helpful that if you can look at a graph of the curve. For example, you should know the basic graph, what basic graphs look like 1 minus x squared or e to the x, right? Just some things that you should know, so that if you are given a curve and you're a little bit hesitant on where to start, at least you have a picture, right? And so remember that definite integrals, we start off doing Riemann sums, right? And so here I have kind of the most important summation notations for Riemann sums, right? So we have the left-hand rule, the right-hand rule, and the midpoint rule. But most importantly, if you can sketch the curve, and if you can draw in those rectangles, and if it's feasible for you to calculate all those areas, go right ahead, in the event that you don't memorize this formula. So just understand that the importance of the Riemann sum is that when we take the limit of the Riemann sums, that's what gives us, right? That's what gets us to the Ftc, right? And so the statements I've written here aren't exactly what the Ftc states. This is a pretty brief, shortened version that you should keep in your back pocket, or in your math back pocket, forever and ever, because these are the two big things, right? So remember Ftc1, that's what we use for the derivative of an integral, right? And the limits of integration are one of them is an x, right? Remember that Ftc, we can only use it this nicely if it's just a single x, right? So if we have cosine, or if we have the integral from a to cosine of x, or a to x squared, the chain rule comes into effect, right? So remember that we'd have to multiply by the chain rule as well once we write in our f of x, right? And then secondly, probably one of the most important things that you'll ever learn in calculus is the Ftc Part Two, which is how we're going to evaluate definite integrals from now on, right? We're going to try and use the Ftc2 as much as possible. So that's just if you take the difference of the antiderivative evaluated at each of the bounds, right? That's going to give us the total signed area under the curve, right? And so that's it on like just integral stuff. So that's a huge piece of the class. Then most recently, what you guys have been starting to do and starting to learn are your techniques of integration, right? And so what the techniques of integration are is, okay, let's say that we don't have a very nice antiderivative that's like just given to us in like in theorem 5.1.2. Well, what do we do about that? Here's what we do. So far you guys have learned substitution, right? So that's u sub, taking apart like a composition and like substituting in u and then canceling out to get du, right? And so here I have just like some key things to remember. The biggest point I think is point number 3, and that's look for u's that, oh, maybe I didn't write it. But anyways, look for u's that you kind of know the derivative of, and look for u's that when you take the derivative, it's very nice and it cancels with some other stuff in the integrand, right? And then the next thing you guys learned was integration by parts, right? And this is just a very handy dandy formula. I've written it both ways. I've written the formula both ways, depending on what you guys prefer. I prefer a UV, so that's why number 2 is written as UV. So just remember that when you're doing integration by parts, the most important thing is that you choose your u functions to be functions that have like very nice derivatives, and when you choose your dv functions, that your functions have very nice antiderivatives, right? So remember, when you do an integration by parts, you are given u and dv, not u and v, right? So you have to find u and you have to find v, right? So those are kind of like the big main pieces that you've learned so far. Can kind of condense all of that down into like 4 maybe like main concepts. But I wish you guys the best of luck on your midterm tomorrow. So that's all from me. I hope you guys thought this review kind of was like a refresher. If you guys didn't know where to start with your studying, maybe after watching this you can kind of be like, oh, well, integration by parts was kind of confusing. Maybe I'll go over that. But yeah, that's it from me. Good luck, guys.